Let's solve an interesting problem involving successive derivatives of a trigonometric function. We start with the function y equals cosine of ax, where is some constant. Our goal is to find a pattern for the nth derivative, which we'll call y sub n. Let's find the first few derivatives and look for a pattern. The first derivative, y sub 1, is negative a times sine of ax. Using the trigonometric identity that negative sine of theta equals cosine of theta plus pi over 2, we can rewrite this as a times cosine of pi over 2 plus ax. For the second derivative, we differentiate y sub 1 to get negative a squared times cosine of ax. Using similar trigonometric identities, this equals a squared times cosine of pi plus ax, or a squared times cosine of 2 pi over 2 plus ax. The third derivative gives us a cubed times sine of ax, which equals a cubed times cosine of 3 pi over 2 plus ax. And the fourth derivative is a to the fourth times cosine of ax, which equals a to the fourth times cosine of 4 pi over 2 plus ax. Let's visualize the pattern we're seeing. For each derivative, the coefficient is a raised to the power of n, where n is the number of derivatives we've taken. And inside the cosine, we have n pi over 2 plus ax. Therefore, we can write the general formula for the nth derivative as y sub n equals a to the n times cosine of n pi over 2 plus ax. To verify this formula, we can check that it works for all the specific cases we found earlier. When n equals 1, when n equals 2, when n equals 3, and when n equals 4. Our general formula gives us exactly what we found through direct differentiation. And that completes our proof of the general formula for the nth derivative of cosine of ax.